Okay, the population P of the USSR was 209 million in 1959. This question is really old, right? Because it's not called USSR anymore, it's called Russia. So we've got the population in 1959, and then it was estimated to be growing exponentially at a rate of 1% per year. Okay, so in this case here, we've got the word growing, haven't we? So that means it's increasing, yeah, population. So if there was a curve for this, it would be going up. So think about the gradient then. The gradient will be positive, yeah? So in A, write down the differential equation which satisfies P. Well, how P changes over time will be dP by dt. And it says growing exponentially at a rate of 1% per year, okay? So it doesn't say proportionally here, it literally says equals. And you might not see that there, but when it says growing exponentially at a rate, it's saying equivalent, right? Equivalent to this at that rate. Because it's exponentially then, you look at the rate, it's 1%. So, of course, when we set up an equation, we can't use percentages, so we'll write that as a decimal. So it's 1%, it's growing at a rate of 1% per year. So as a decimal, that's 0.01 of the population. So we say 0.01p. Okay, so that's the rate at which is growing at. That's the differential equation there. dP dt, population is changing over time, okay, at this rate here, at 1% of the current population. So there's my differential equation. What we do then is we separate, okay, so we separate the variables. Again, we've seen this now quite a bit. Leave the 0.01 where it is. The p is on top as well, but just take the p over. So we have 1 over p dp equals to then take the dt up times that. So 1 over p integrated becomes ln p. 0.01 which is dt becomes 0.01 t plus then my constant, of course, of integration. Okay, so we can work out the constant because they give us sort of information here, don't they? So it says the population P of the USSR was 209 million in 1959. So if we think of this as like the start in 1959 when T is 0, okay, and because at that time it was estimated then that it would be growing at this rate. So yeah, we'll go with that then, yeah, T is 0. So when T is 0, population, now let's just put 209, okay, rather than writing it out in full, or we can put 209 little m if you want, okay, or should we go for all the zeros? Let's go for all the zeros. 209 million, okay, just because when we put it in, you know, if I just put 209, it looked like it is 209, even though we know it's 209 million. So 209 million is equal to, well, T is 0, so 0.01 times 0 plus C. So C is equal to ln 209 million. Okay, so therefore ln P is equal to 0.01 T plus ln 209 million. Okay, so you know perhaps what I'm going to do now. I'm going to sort of solve this differential equation. Let's take that ln over. So I have ln P, take away ln 209 million equals to 0.01 T. Of course, two logarithms taken away, we can write it as a single logarithm. And we divide. 0.01 T. Get rid of the ln, take it over to the side, so you're doing the opposite and your inverse separation, which is E. So you've got P over 209 million equals E to the 0.01 T. Okay. And then take that 209 million up there. So P will equal to 209 million e to the 0.01t. So in B, the question asks, what is the value predicted to be in 1980? Okay, so if you think about it, in 1980, t will equal to 21, yeah? Because from 1959 to 1980 is 21 years, yeah? Yes. So the population will be 209 million. It's only a prediction, of course, right? The model. Okay. Based on the growth back in 1959. So that this might not actually have been the population in the 1980s. Worth checking, or maybe. So if I type that into my calculator, 209 million e to the 0.01 times 21. Okay, I get this here. So the population will be 257,838,714, or 15 if we round it. Okay. Clearly we can't have 0.5 of a person, so we can round it. So that would have been the population there. And it says, when will the population be double that of 1959? Now, what is best to, in that case then, double it? Obviously, in 1959, the population was 209 million. Double it, it would be 418 million. What's actually good is, don't use this equation. Go back to this one here, because it's much easier to deal with. Okay, so in other words, you have, so in star, okay, when population is double, okay, P will equal to 418 million. So ln 418 million divided by 209 million equals to 0.01t. Now 418 million divided by 209 million is just 2, isn't it? So that'll be ln 2 is 0.01t. So therefore t will equal to ln 2 divided by 0.01. Okay, so let's just do that. ln 2, and we get 69.3 years. Okay, so when will the population be double that of 1959? Well, if we do 1959 add 69, excuse me, we get roughly 2028. Okay.